Hi ladies and gentlemen, I'm back again. We are still on the topic of Senior 6, which is Unit 1, Complex Numbers. And we are almost at the end, where we are just dealing now with the applications of complex numbers. This means where we use them and why are they there. So applications of actually complex numbers, there are many. So there are many, but here I've decided to share with you some of them. Maybe others, they are very easy. You can read through notes on our website and get it. But I have just decided to share with you the most ones and the most used ones. So here we are on the second one. Last time we shared together how we find the trigonometric expression of multiples of angles. So now today, ladies and gentlemen, we are here to see how can we use complex numbers to linearize trigonometric expressions. And here now, ladies and gentlemen, we should be dealing with the formulas of product to sum. There will be expressions in the product, and then we express them to sums. And now, ladies and gentlemen, I will tell you that this is very important, because we shall need this when we reach again in Senior 6 on a unit called the integrations. In integrations, they will give us an expression which is in product, and we shall need linearization first to linearize the expression in sum and put it in sum, and then after putting it in sum, it will be very easier to integrate. So that's why I invite you to follow this very important lesson. Ladies and gentlemen, I have told you that we use here the Euler's formula. We use the Euler's formula in linearization. In linearization, we use the Euler's formula. Do you remember them? We have seen that the Euler's formula are these ones. We have seen cos theta, cos of any angle. It can be theta, it can be x, it can be any angle t, whatever. Cos theta was equal to e power I theta plus e power negative I theta over 2. And we had again that sin theta will be equal to e power I theta minus e power negative I theta over 2i, ladies and gentlemen. These are the Euler's formula, and these are the ones we are going to use for linearizing trigonometric expressions. Now, more generally, there is like how they are looking more generally. If you look in a general sense, so we shall see that if I have like cos n theta, if I have cos n theta, remember it is not always just that we shall have cos theta. It can be cos 2 theta, it can be cos 3 theta, or any other multiple angle. So we shall have now cos n theta, that this will be equal to e power I theta. Power I now, instead of having theta, we have n theta plus e power negative I n theta over 2. And we shall see that sin now, ladies and gentlemen, sin n theta, this will be equal to e power I n theta minus e power negative I n theta over 2i, ladies and gentlemen. This will be when we want to make it more generally, either the Euler's formula in a general way, when we want like to have other multiples of angles in the multiples of angles. So we shall use this formula, which means that I can even find cos 2 theta, which will be equal to e power 2 theta plus e power negative 2 theta over 2. These two will be always there, and if it is cosine, it is plus, if it is sine, it is negative here, ladies and gentlemen. So, ladies and gentlemen, we shall just use this Euler's formula to linearize any trigonometric expression. So here is an example we are having, and ladies and gentlemen, you will be able to understand very well. Now, I will give you an example, which is to linearize. So it's to linearize the x, linearize just sin x cos squared x, linearize sin x cos x. Let us just do it. So what do we do now, ladies and gentlemen? We shall find an answer here. What do we remember? Remember one thing. Remember that, ladies and gentlemen, that cos x will be e power ix plus e power negative ix over 2. Remember again that sin x will be e power ix minus e power negative ix over 2I, ladies and gentlemen. Thank you very much if you understand that. Now, we have an expression. The expression is sin x cos squared x. Now, we replace sin x by what is here from the Euler's formula. So we have now sin x, which is e power I theta. So now we don't have theta, but rather we have x minus e power negative ix over 2I times what? E power ix plus e power negative ix over 2. All of this squared. Ladies and gentlemen, remember one thing. This is cosine squared, this is sine. So we have just done nothing rather than this. Now, we go. Ladies and gentlemen, I invite you to follow because I will be jumping some small steps because the table is small a bit, but I will invite you to follow. You will understand. So here, ladies and gentlemen, we have this 2I and we have here 2, but squared, which makes it 4. Now times 2I, which makes it 1 over 8I, ladies and gentlemen. This is 8 because there is this 2 here, times 4 from there. 2 squared, which makes it 4, times 2I, which makes it 8I. Now, ladies and gentlemen, this go aside. After this goes aside, ladies and gentlemen, we have now to remain with e power ix minus e power negative ix. All of this, again, I multiply with this squared. With this squared, I use again the binomial theorem. We all remember what is a plus b squared, which is, of course, a squared, which will be 2ix plus 2eix times e power negative ix, because this is 2ab. Then finally, plus b squared, which is e power negative 2ix, ladies and gentlemen. It's just expanding by binomial theorem. Everyone can understand this. So, ladies and gentlemen, we have this. We still have 1 over 8I. We now multiply it to what? Remember here, one thing that you have to observe, ladies and gentlemen, is that this, because it's multiplication, the bases are the same. This is like, when we have the same bases, we add the exponents. And if we add the exponent, we have now ex, it will be like e power ix minus ix, which will be, of course, e power 0, and this is 1. So here we have like 2, and these ones will remain in. So I will also expand this. I have to expand this. So I take this, I multiply to this. So, ladies and gentlemen, I will have now to add the exponents as the powers are, I will add the exponents because the bases are always the same, they are e. So e times this, I will now get e ix plus 2ix. Is everyone seeing this? Which will make it now e power 3ix, because it is ix plus 2ix. And then I take this, I multiply to 2, and I get 2 e power ix. And now I take again this, I multiply to this. I'm just doing distributivity. So I will get now e power, I again add the exponents, I get minus ix. I take this, I multiply to this, and I get negative e power ix, ladies and gentlemen. I take again this, I multiply to this, I get negative 2 e power negative ix, ladies and gentlemen. And I take this, again I multiply to this, I add always the exponents, and I will get negative e power negative 3ix, ladies and gentlemen. This is the answer. So, later on, I'm not sure whether it will fit here, but we just need to change. So later on it will be 1 over 8i factor again what? I put together, ladies and gentlemen, all those things with the same terms. So here you have e power 3i. E power 3ix, then minus e power negative 3ix. You see these ones have the same water, the same powers. So they go together. So I have also this is plus, ladies and gentlemen, it's plus 2 factor e power ix minus e power negative ix. Here I have grouped together this and this. We shall also have these 2 here, ladies and gentlemen. This will be minus e power ix minus e power negative ix, ladies and gentlemen. And I close this one. So later on, ladies and gentlemen, we can see if we have it clearly. This will be this. If I try to write it better, this will be sin x cos squared x, which will be equal to 1 over 8i factor e power 3ix minus e power negative 3ix plus 2 factor e power ix negative e power negative ix minus e power ix minus e power negative ix, ladies and gentlemen. Now, I invite you to follow me very clearly here, ladies and gentlemen, and follow the exercise I'm going to do, which is very important for your understanding. Now, ladies and gentlemen, observe, we are almost at the end. We are almost at the end, really. So, follow me. We here have e power 3ix minus e power negative 3ix. As you can see, ladies and gentlemen, we miss a small thing. If you allowed, I could ask you what the thing is. But I think is none than, if we divide here by 2, ladies and gentlemen, following the general formulas of Euler's formula, we shall see that if we divide this by 2, we shall have something very important. But if we divide by 2i, because there is negative, we shall need now side of something. So here we shall have now, ladies and gentlemen, this is 1 over 8i. This is very confusing. I ask you to follow. So if we divide by 2i, it is easy to see that this will be equal to sin 3x. Okay, ladies and gentlemen, this is easy to see that because we have negative here and we have n, which is 3. This is it's like sin 3x if we divide by 2i. But dividing by 2i, there was no 2i there. So because there was no 2i here, we also multiply with 2i here. This is very tricky. This is, I divide by 2i and I multiply by 2i. When you take a fraction and you multiply on both the numerator and denominator by the same number, it doesn't change. It remains the same. So here we shall have now 2i sin 3x. Now going to this one, it's the same. You will see that because we have here negative, it's very easy to see that if we divide by 2i, we shall get now sin x. But because we have divided by 2i and it was not there, we shall also multiply by 2i here up. And ladies and gentlemen, this will be plus 4i sin x. Ladies and gentlemen, we go back here. We also divide by 2i so that we can get negative sin x. But we have divided by 2i, which was not there. We also multiply by 2i. And I have again 2i here. This is very tricky but clear. I think that if you have understood this step, you will understand. My ladies and gentlemen, suppose here there was like plus. For you to understand better maybe. If here there was plus, I could divide by 2 and get cosine 3x. Because it is plus. But because it's minus, it is a sign. So ladies and gentlemen, now we expand, we are about the end. So we get now 2i over 8i. This is 2i over 8i sin 3x plus 4i over 8i sine x minus 2I over 8I sine x, ladies and gentlemen. And after this I go with this, 2 goes with this, we remain with 4. We simplify I with this, by 4 we get 2. We simplify this and this, by 2 we remain with 4 here. Ladies and gentlemen, we have similar things. These two are similar. We have sine and sine here. And we have, it is actually 1 over 4 sine 3x. And then we add together this. This is a half and this is a quarter. A half minus a quarter, if we put that to the common denominator, it is plus, I put there 4. 4 divided by 2, I get 2. 2 times 1, I get 2 sine x minus sine x. And ladies and gentlemen, this will be finally equal to 1 over 4 sine 3x plus sine x over 4. And this is the final solution. Ladies and gentlemen, you will see that this expression was quite complicated. It was a product, and now we have expressed it into a sum, which is linearized. It is really simple. And this now, as I told you, we shall need this in integration in another unit that we shall see later on. So if you have integration of this expression, it will be very hard to you to integrate this. But after realizing it and be this one, it will be very easier to integrate this and get the answer. Ladies and gentlemen, this is the end of our lesson, but you have followed me on how I do the things, on how I find the linearized form of this expression. And now, ladies and gentlemen, I will invite you to go back and try this in another way, in another exercise I will left you with. So here, ladies and gentlemen, I will need to review with a small homework that everyone will try. Everyone will try this homework, and we'll just check whether he or she have understood very well what we learned here around, ladies and gentlemen. So the homework of today is for you to realize this. I will leave you with this homework. So linearize the following expression. So number 1, the expression number 1, ladies and gentlemen, is 2 sine x cos y. And ladies and gentlemen, for this one, if you reach to a very simple solution, I will just leave you with an answer. If you find this, ladies and gentlemen, you will be very right. If you find sine x plus y plus sine x minus y, this will be very right after linearizing. Ladies and gentlemen, if you reach there and you found that you have done the thing, you can just congratulate yourself and say you have done something great. You will also try this. You will also try this. Number 2, you will try now to find also the linearized form of sine squared x cos squared x. The answer, I will ask you to just go to see that in the notes. You will find it in the notes. Ladies and gentlemen, you can see the lesson was very interesting, and it is the end of this topic or this lesson we were having here on how to linearize trigonometric expressions. Ladies and gentlemen, I will tell you that there are many applications of complex numbers. Among others, there are even how we solve some trigonometric equations using complex numbers. It was actually another application, but we find it in the notes. Ladies and gentlemen, I invite you to check the notes and read them for more understanding, for all of the things that are there, or for more details. And if you get any confusion, you will come to look for our videos, which will help you to understand better all whatever we have learned here so far. Ladies and gentlemen, our website is none other than www.ubumenyi umeyi.net. And ladies and gentlemen, if you go to this website, you will just have to create an account there, and ladies and gentlemen, we'll be able to talk to the teachers. You will be able to just receive other lessons. Biology will be there, physics will be there, chemistry will be there, mathematics will be there, everything. Ladies and gentlemen, I invite you to go to this website and make sure you create an account there. After the account, you will be able to get the notes. For any teacher, you will be able to interact with any teacher you want. You will be able also to receive notes. You will be able to request for evaluations, for exercise, more exercise and whatever. Ladies and gentlemen, this is a virtual class. I invite you to go there and you'll find everything there. Ladies and gentlemen, this is not enough for you. We have thought about you, and we have also made another YouTube channel. It is Ikaram TV. So if you go to Ikaram TV, ladies and gentlemen, you will be able to subscribe first. When you subscribe, you will be able to get all the videos on update, daily basis. So ladies and gentlemen, I invite you to go to Ikaram TV, where you will be able to get all the videos. And I'm telling you, don't forget to subscribe first and to share to your friends. So remember, knowledge is shared. It's not for you only. You have to share to others. Share to your friends. Ladies and gentlemen, you will find here all the videos that have passed previously and those which are coming. We are still coming. So ladies and gentlemen, we are now ending Unit 1, which was complex numbers. And I'm now going to go to the next units. Either for Senior 6, you'll be finding me there. For Senior 5, Senior 4, you'll find me there. I invite just you to go to the website and remember you create an account here, and remember you subscribe on our YouTube channel for every update on what we are doing. Thank you very much. I love you. It was Teacher Walter, and I wish you all the best success and whatever we are here for you. Thank you. We love you.